OSPF behaves a little bit differently on a multi-access network than it does on point-to-point networks. Now, in OSPF's view of the world, a point-to-point network is a network that only has two devices on it. So the router on one end and the router on the other end. A multi-access network, of which far and away the most common one is Ethernet, is a network in which multiple devices will be connected to the same network. So what you see here is 4 routers connected to a switch. So this is an Ethernet multi-access network. Now, before we dive into it, let's take a look at what we've got here. So we see our 2 routers, our 1, 2, 3, and 4. We see our IP addresses for our connection 192.168.1.0 and then .1.2.3.4. At this point, routers are configured. OSPF is enabled, but it's not configured at all. So, whether it's enabled and it's activated on the interface. We'll take a look at that here in just a second. But we haven't done anything to manage OSPF on a multi-access network. And what happens here? In a point-to-point network, the 2 devices create an adjacency and they share information back and forth. Well, if that were to happen here, and this wouldn't be bad because there's 4 of them, but what would happen is R1 would create an adjacency with R2, with R3, and with R4, and then anytime it got an update, it would send it to all 3 of them, and then they'd all have adjacencies with each other, and so R1 would take its update and send it to R2, R3, R4. R2 would say, hey, I got an update from R1, let me share it with R3 and R4. R3 would say, hey, I got an update from R1, let me share it with R2 and R4. And this just gets really convoluted in a hurry. So what happens on multi-access networks is OSPF, recognizing it's a multi-access network, elects what's called a designated router. And the designated router manages all of the updates. So let's say R1 is our designated router. I'm going to make a note here because we want to make R1 our designated router, or DR. So I want this one to be my designated router. Alright, so what should happen is if R4 has an update, and by the way, pretend each one of these has other networks attached to them. It's the only way this makes sense. So let's say an update happens out here, and R4 gets it and it forwards it to R1. It doesn't forward it to R2 or R3 because it doesn't have that same type of relationship with them. So R1, the designated router, then takes it and shares it with everybody else. So R1, the designated router here, is pretty significant. But what if, just move that down a little bit, what if the designated router goes down? Well, in that case, we have a backup designated router. So I'm going to make another note here. We're going to have a backup designated router, or BDR. And let's say in this case we want to make R4 our backup designated router. Go and throw that on top there for consistency's sake. Okay, now we've got our backup designated router. The designated router goes down. The backup designated router becomes the designated router. And then amongst everybody else, who's referred to, by the way, as DR others, one of them will be elected to become the backup designated router. Okay, I've enabled OSPF, but I have not managed or controlled this process whatsoever. So let's see what we've got here. I'm going to go to R1 and get logged in. And I'm going to do a show IP OSPF neighbor. Now, this is going to tell me I have 3 neighbor adjacencies, or 3 neighbor relationships. And notice these are all based on IP address. I haven't set a router ID yet. We have our adjacencies over here. So 192.168.1.4, we have a full adjacency, and it is a DR, so it's a designated router. I don't want it to be the designated router. I want R1 to be the designated router, but I didn't control it, so this becomes a designated router. My backup designated router is 192.168.1.3, that router ID. And again, I don't want that router ID, and I don't want it to be the designated or the backup designated router. I want R4 to be the backup designated router. Okay, let's talk about how these get elected. The preferred way to choose a designated router is by priority. So let me do a show IP OSPF interface G00, which is what all these are connected to. Okay, so here's interface G00. Let's take a look at this part of this one right here. So state DR other tells me what I am. I'm a DR other, and I have a priority of 1. Now 1 is the default priority. All routers are going to have a priority of 1. So highest priority becomes designated router. Second highest priority becomes backup designated router. But if everyone has the priority of 1, then we have to have another way of choosing. And the way we do that is based on router ID. So the highest router ID becomes the designated router. Down here you'll see we have 2 other lines which give us our neighbor count, adjacent neighbor count. Neighbor count is the total number of neighbors that we know about. Adjacent neighbor count is the number of routers that we have an adjacency with, which should be 2, by the way. It should be the designated router and the backup designated router. And notice here on our router IDs, 192.168.1.4 is the highest router ID, so it became designated router. 192.168.1.3 is the second highest, so it became the backup designated router. Okay, I'm going to start by changing my router IDs. So remember from our previous video, OSPF has to have a router ID. The preferred way to do that is to set it in OSPF configuration. If you don't, then it's going to look for the highest IP address on a loopback interface, and if it doesn't have any loopback interfaces, it's going to take the highest IP address on a physical interface and is going to make that the router ID. Okay, so let me start by adjusting my router ID. I'm going to go to config T. Router OSPF 1 router-ID 1.1.1.1. Okay, and exit. Show IP, nope, I don't want to show IP that. Show IP protocol. Now that's going to show me my router ID, but notice it shows my router ID here, but here it doesn't reflect my new router ID. Okay, if I do a show IP OSPF, it's going to show me I have ID of 1.1.1.1, but that actually hasn't been updated. All of my neighbors, let me go to R2 here, and do a login first. Show IP OSPF neighbor. Alright, that now has finally gotten around to updating. Let's go ahead and set the rest of our router IDs. So I'm on R2, so I'm going to go to config T, router OSPF1, router ID, and I want to make this one 2.2.2.2. And I'm going to go to R3. Try that again. Router OSPF1. Whoops. Config help first. Router OSPF1. Router ID 3.3.3.3. And then to R4. Whoops. Config T. Router OSPF1. Router ID 4.4.4.4. Okay, so now we've updated our router IDs on everything. Let me come back to R1 and see what we've got. Show IP OSPF neighbors. Okay, so our router IDs have updated. Now, in some instances, you will run into a situation where the router ID does not update until you restart the OSPF process. And the way we do that is just clear IP OSPF process. And that says, do you want to reset all processes? You can specify a specific number if you want to do just a particular number. So if I've got more than one process, I can say do 1, don't do 2. I'm going to say yes, I want it to restart. That takes down all of my adjacencies, wipes everything out, restarts the process, and I come up with, if your router ID doesn't update automatically, I come up with a new router ID. Show IP OSPF. OSPF. There we go. Okay. And we should see at that point our new router ID if it doesn't happen automatically. Alright. Now, that did not actually help with my designated router stuff. Show IP OSPF neighbor. And 4 is still my designated router. 3 is my backup designated router. I want 1 to be my designated router. So what I'm going to do is I am going to set the priority, which is the way you want to configure it, this preferred method. So the way we set the priority, we go to config T and we go into our Ethernet interface. So we're going to set the priority on. And remember, this is for any multi-access network, although we're doing it with Ethernet because that's the most common one. So the command is IP OSPF, and then we're going to specify which OSPF process. Set the priority, and the priority can be a number. The OSPF priority. There we go. I don't have to set the number. Priority, not pro. There we go. All right. So it can be a number from 0 to 255. 1 is default. A higher number wins. 0 means this device will never, ever, 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 ever be a designated router. You want to do that if you've got a router that's older and participating in the process, but you don't want to take the extra workload. You might want to do that. I'm going to set this one because I want this to be the designated router. I'm going to set it to a priority of 100. And then exit. Show IP OSPF interface G00. And now you'll see that our priority is 100. But notice that we have not changed state. We are still a DR other. It hasn't made us the designated router. And that's because adding a new device in or changing a priority does not trigger a new election. My designated router is still 4.4.4.4. Now, in order for this to change, I need to take my designated router offline. And this becomes a little problematic, but there is a way that we can do it. In fact, we've already seen it. Let me start by configuring my backup designated router. So I want R4 to be my backup designated router. And I know that it would work, right, if I just leave it this way because it's got the highest priority or the highest router ID. But what happens if I add a new router ID with a new router in with an ID of 5.5.5.5? Then that would take over instead of 4.4.4.4 because it would be higher. So what I'm going to do is I'm going to set my priority, preferred method, right? So config T interface G00 IP OSPF priority, and I'm going to make this one 50. Okay. End and show IP OSPF interface G00. Now you'll see it's still the designated router. The priority is 50. Okay. And 3.3.3 is my backup designated router. Okay. I need to change it. So I can take this device offline, which means I can shut it down, or I can kill its interface that it's connected to this network on, or I can clear that IP OSPF process. Clearing the IP OSPF process is the least damaging one that we can use. So I'm going to run that. Clear IP OSPF process. And yes, I want to do all of them. Now, this takes me down and back up, but it happens pretty quickly. show IP OSPF neighbors. There we go. And now you'll see 3.3.3.3 is our designated router, or is our backup designated router. Let's wait for this thing to finish its selection, shall we? So, do show IP OSPF neighbor. Okay. Show IP OSPF interface G00. This thing still thinks it's a designated router. Alright, what I'm going to do is I'm going to copy, run, start. And then I'm going to reload this device. And that should clear it. And this will take just a second. Clearing the IP OSPF process is faster and less disruptive to your network. This will accomplish this task. Hopefully. Show IP OSPF neighbor. And OSPF hasn't finished configuring yet. So we'll give it another second or so. Let's do a show IP OSPF interface G00. So we're still in the waiting state. That's okay. The reason we're in the waiting state is because it took a while for this to come back up. I forgot about waiting for STP to run. Okay, where are we at? Still waiting. We'll give it a, you know what? There we go. I was just going to skip process, but that's okay. Took too long, I figured it out. So, show IP OSPF interface G00. We are, the designated router is now 3.3.3.3. We are designated router other. Well, that's not what we wanted. We wanted it to be the backup designated router. And now notice the 1.1.1.1, which has our priority of 100, that's the backup designated router, while 3.3.3.3 is the designated router. What gives? This isn't what we were looking for, right? Okay, here's what happens. When your designated router goes down, the backup designated router always gets promoted to the designated router. And then there's an election for the backup designated router. That's why 3.3.3.3, which was our previous backup designated router, gets automatically promoted, even though it's only got a priority of 1. The backup designated router, then there's an election. So let me move this out of the way. 3 gets automatically promoted. The remaining DR others, which were 1 and 2, they have an election, and highest priority wins, so this becomes the backup designated router. Which means if I want this to become the designated router, I have to do the same thing over here to R3. Close my previous window over there, and I'm going to go to R3. And this time, instead of rebooting it, I'm just going to shut down the interface. Config T, interface G00, shut down. Okay, now close that for the moment, and I'm going to go to R1. And now let's see what we've got. And we'll do this before we bring R3 back up. Show IP OSPF interface G00. Now, this one is backup designated router, priority of 100. Our designated router is still listed as 3.3.3.3, but that's going to go down here in a second when it realizes, there it did, that 3.3.3.3 went down. So, back to our IP OSPF interface. Now we are designated router with a priority of 100. Also notice 2 and 4 then had an election, and 4 became my designated router, and that's what I wanted. I wanted R1 to be my designated router, R4 to be my backup designated router, and that's exactly what we've got. Now let's go ahead and bring R3 back up. So we'll connect back to it, and we'll do the command no shutdown. Now it's going to take it a few seconds because we need the STP process to run on the switch, and a couple of other processes. So I'm just going to fast forward time here a couple of times. Alright, and now from R3, we're going to issue the command show Ip Ospf interface G00. And now we're going to see neighbor count is 3, adjacent neighbor count is 2. We're adjacent with 1.1.1.1, our designated router, and 4.4.4.4, our backup designated router. We are DR other. That's perfect. That's exactly what we wanted to do. So you'll notice we've set the priorities, and then we got to jump through some hoops in order to get it to work. Now, something else for you to be aware of here. If I shut down all of my routers at the same time, and they all come back up at the same time, then that priority will always win out. However, if they don't come back up at the same time, it is possible that one of what's supposed to be my designated router comes up after there's already been an election and we've already chosen another designated router. If that happens, I have to go through this process of disconnecting, shutting down, or hopefully just clearing the process if that'll get it to take, in order to bring my selected designated router, get it elected back up to where I want it to be. One last thing I want to show you here. I'm going to do a show Ip Ospf neighbors. Alright, here are my priorities, my state, of all of my neighbors. Both of these show a full adjacency. You should always have a full adjacency with a designated router and a backup designated router. You should always have a full adjacency with basically anything except a DR other. That will always be a two-way. If you do a show an Ip Ospf neighbor and you see a two-way relationship with anything else on a point-to-point network with a DR or a BDR, if you see a two-way relationship with anything else, it means something's wrong with OSPF and it's not forming an adjacency correctly. The only time you should ever see two-way is when you're looking at a DR other. So, do the show Ip Ospf neighbors. If you ever see anything else, wait about 30 seconds, give it a try again. If it's still not coming up, we have a problem with OSPF and it's not forming adjacencies correctly. Once it's once you have that full adjacency, they're exchanging information, they're exchanging routes, and everything's good. But if you ever see anything else other than a DR other, you've got some troubleshooting to do.